Hello everyone. In our few lectures we have studied about Legendre polynomial, Legendre polynomial, in which we have studied the differential equation, and its solution, and another one generating function for generating function of Legendre Legendre polynomial. Alright. So the differential equation was 1 minus x square d square y upon dx square minus 2x dy by dx plus n plus 1 y is equals to 0. So this we had calculated the solution for this differential equation, and the generating function sorry, generating function, whereas the generating function generating function was what? 1 minus 2x z plus z square to the power half is equals to summation n equals to 0 to infinity z to the power n p n x, where p and x is Legendre polynomial. Alright. On expanding left hand side, we will find z to the power n to be p and x. So we can say this is the generating function for Legendre polynomial. So on behalf of this, we will calculate some numerical. So our first problem is prove that what 2n plus 1 x p n x, alright, n plus 1 p n plus 1 plus n p n minus 1. This is subscript n minus 1. I can write it x. We know it is known to us what pn is a function of x. So for this we need what? Generating function of Legendre polynomial is 1 minus 2x z plus z square to the power minus of half is equals to summation n equals to 0 to infinity z to the power n p n x just differentiate I want to get a differentiating equation 1 with respect to what? With respect to z. Alright. So for the left hand side, this will be minus half of what? 1 minus 2x z plus z square minus half minus 1, that will going to be 3 upon 2, and for the inner side it will give me what? On differentiating this, first term will give me 0, this will give me minus 2x plus 2z, good, which is equals to summation n equals 0 to infinity n z to the power n minus 1 p n x. Alright, just simplify this one, so I can write it as If I take 2 common from both the terms, so this will become, okay, I will write as it is 2xz plus z square to the power minus 3 upon 2 minus half multiple factor of 2 of x plus z minus x plus z, which is equals to summation n tends to 0 to infinity n z to the power n minus 1 pnx. Alright, I just cancel out this 2 by this 2 factor and just multiply minus 1 inside. So this final result becomes 2xz plus z square to the power 3 by 2. X is going to be positive because of this negative sign minus z. Alright, I just multiply minus 1 with these 2 factor is equals to n is equals to 0 to infinity and z to the power n minus 1 pnx. Good. Now we will multiply this equation, above equation, say this equation 2. Alright, multiplying equation 2 with, or we can write, multiply equation 2 by 1 minus 2x z plus z square, both the side. Alright, both the side. So if I multiply this with this factor, so this quantity becomes here, but 1 minus 2x z plus z square to the power minus half. Alright, x minus z, and for the right hand side, if I just separate this infinity n z to the power n minus 1 multiply by 1 minus 2, this term 1 minus 2 xz plus z square pnx. Alright, I know this is my generating function for Legendre polynomial. So instead of this, I can write it as what? I can write it as this term x minus z as it is, and this term will be treated as what? Summation n 0 to infinity z to the power n pnx. Why? Because I know the genetic function for Legendre polynomial is 1 minus 2x z square to the power minus half, which is equals to summation n tends to 0 to infinity z to the power n pnx is equals to summation n tends to 0 to infinity n z to the power n minus 1 1 minus 2x z plus z square pnx. Alright, now we will equating the coefficient, equating the coefficient, equating the coefficient of z to the power n, equating the coefficient z to the power n from here. So this will give me what, or we can say will we have what, just multiply x pnx, first term will be x pnx minus of what, if I multiply z with this term, so for this we will have z to the power n plus 1. If I multiply this whole term with this, for the first term I just multiply x with this term, so this will give me what, x z to the power nx pnx. For the coefficient of this z to the power n, we will have x pnx only. For the second term, if I just multiply here, so we will have the power of z n plus 1, but we need what, we need z to the power n. So this is in series form. So here n must be what? N must be n minus 1. If I put n here, n minus 1 in this form, so the power will be Zn. So we will have what? Pn minus 1 x here. Alright, just remove this one. For the right hand side, if I multiply this term with our first term of this, so we will have what? For z to the power n, where n must be n plus 1 here. This is in a series form. So in this form, where we find z to the power n, when z to the power n must be what? Z to the power, the value of n must be n plus 1. Now substitute here, z to the power n plus 1 minus 1 will give me z to the power n. So the for first term, if I multiply with this term, so n must be what? N plus 1. So here no coefficient, so it will give me n plus 1. We will replace n with n plus 1 here, and p n plus 1 x. Now if I multiply this series, if I multiply this series, if I if if I multiply this series, just move this. If I multiply this series with this term, so this will give me what? 2x n z to the power n minus 1 dot z on both together that will give me what? Z to the power n. So here no need to change the value of n, so it will give me minus of 2x n pnx. Alright, now for the third term, for the third term the third term, but if I just multiply this series with this term, look at it. So z to the power n minus 1 plus 2 from here, so it will give me z to the power n plus 1. So but I want z to the power n. Z to the power n will be available when n is equals to n minus 1. Just put n here, n minus 1. Yet n minus 1 plus 1 will give me z to the power n. So now for the third term we need pn, n must be what? N minus 1. So this must be plus 2 n p n minus 1. Sorry, n will be replaced by n minus 1. N minus 1 p n minus 1 x. Just rearrange this. Alright, pnx here. Just take this one left hand side and this minus right hand side. So we will have x pnx plus of 2xn pnx is equals to n plus 1. This will be same pn plus 1 x plus of n minus 1 pn minus 1 x. This will give me plus pnx pn minus 1 into x. Alright, if I simplify this, so from here we can, if I take x common from both the term, so the residue will be 2n plus 1 into x pnx is equals to, this will be same as n plus 1 pn plus 1 x. Here one term is, this will give me what? N pn minus 1 x negative of pn minus 1 into x positive of pn minus 1 into x. This will cancel out. So the final result will be 2n plus 1 x Pnx is equals to n plus 1 Pn plus 1 x plus n Pn minus 1 into x. So this what we had required to prove. Alright, 2n1 is x Pnx plus n plus 1 Pnx n plus 1 and Pn minus 1 into x. So this can be asked as a recurrence relation. It can be a recurrence relation, or it can be asked as question. Alright, so this will how we will derive. Alright, okay. From if we take another question from generative function of Legendre polynomial, question 2. A question says the generating function say f x comma t is equals to summation n tends to 0 to infinity Pnx t to the power n for Legendre polynomial Pnx is here given f x comma t is equals to 1 minus 2xt plus t square half t. The value of p3 minus each options are given. Option A 5 by 2, option B 3 by 2, option C 1, option D minus 1. Alright, so we have given a generative function fx which is equals to, which is a function of x and t, which is equals to summation n0 to infinity Pnx t to the power n for a Legendre polynomial Pnx, where fx is given 1 minus 2xt plus t square to the power half minus of half. Find the value of p3 for minus 1. What will be the value? So the option A 5 by 2, option B 3 by 2, option C 1, and option D minus 1. We already know generative function generative function for Legendre, generating function for Legendre polynomial is Legendre polynomial is 1 minus 2xz plus z square minus half into summation n tends to 0 to infinity z to the power n Pnx. This we already know, but here just z is replaced by t. So the question says we have f x comma t is equals to 1 minus 2xt plus t square to the power minus half, which is equals to summation 0 to infinity Pnx t to the power n. Simply, for in question we know we have to calculate what p3 minus value. That means we need x equals to minus x. So simply we need to put x equals to minus 1. Put x equals to minus 1 in the above question, in this equation, in equation number 2, in equation 2. So we'll have what 1 minus, if I multiply minus 1 with this minus, so this will give me plus of 2t plus t square to the power minus half summation tends to 0 to infinity Pn minus 1 t to the power n. Alright, just to simplify this, I can write this in a square form. So this must be what? 1 minus t to the power 2, its whole power minus half. If I expand this, 1 plus t whole square equal 1 plus 2t plus t square. So this is the same. So I can write this edge in square of 1 plus t to the power 2 whole power minus half is equals to summation is to 0 to infinity Pn minus 1 t to the power n. Alright, now so this becomes 1 plus t to the power minus half. Alright, which is equals to summation and tends to 0 to infinity Pn minus 1 t to the power n. Just expand left hand side. So power is minus 1. It will give me 1 minus of t plus t square minus of t cube plus t4 minus alternatively it will give me minus n plus, which is equals to n to the power 0 to infinity p to the power n minus 1 t to the power n. In our question we need to calculate p3 for minus 1. So p3 is, this is for p0, this is for p1, this is for p2 and this is for p3. Alright, so the coefficient will be minus 1, t3 here, t3 here. Alright, if I expand this one, so this will give me what? First term p0, then after t p0, sorry p1, t p1 plus then after t square p2, then t cube p3. So for p3 the coefficient will be minus 1. Alright, so p3 will have this minus 1. So the correct option will be, or we just simply write here, on comparing the coefficient t cube on the both side, on the both side we get what? We get p3 from here. So p3 for minus 1 will give me here minus 1 value. So the correct option is D. Correct option will be good. So by this formula we can calculate our recurrence and we can solve numericals too. So on our last upcoming lecture we will study the Roderick formula for Legendre polynomial and we will see the graph in Mathematica. Thank you.